Okay, so now I'm going to talk about inheritance and how you can use all the functions of a class mover, have a different class that is a type mover. So just before I get started, I want to look down here at our particle system and know that when you add a mover, right here, mover, that is the only place uh, in the functionality that specifically calls mover. All of the rest of the times it just says for m in self m list, and this mover doesn't refer to, it's just whatever object is inside of our m list, apply force to that object. So in theory uh, we could do confetti right here, and so whatever our confetti class object would be, as long as it works in the same way that our mover object would work, we could do this. Of course, it's not going to work because we haven't written a confetti class yet, but let's go ahead and do that right now. So here I have my class particle system. Up here I have the mover system, and when we call init on it, we do self, position, velocity, acceleration, and mass. So our confetti thing is going to be, it's going to be of a type mover. So we need to do this right here. In Python, this is what you tell. This tells Python that confetti is really it's of the type mover. So def init and I want to do position, velocity, acceleration, and mass as well. So I want to our confetti to, we're going to pass in the same information that we would for a mover, and so to create this thing we need to call mover dot init. And what does mover.init, what does that what does that take? It takes self, position, velocity, acceleration, and mass. So, but this self refers to this confetti object. That's a little bit confusing, so if you need, if you don't want to think about that, don't. But just know that we need to, if we want this to be, if we want a new class object to be of a type something else, we need to put that type in here. And then in the init, we need to call the init of that type. There's a lot of exceptions to this rule, but that's what we should worry about right now. So I'm testing it. It says it's completed successfully. So down here, confetti. So now our particle system is full of confetti objects. It's not mover objects anymore. They're confetti objects, which are of a type mover. So let's check this to see if it's running. Okay, and it is. It's running just the same. So basically, that little setup is to kind of show that our confetti, it has all the same functions as our mover. So you could do, so now inside of our particle system, if you look, this M list, inside of our M list we have confetti objects. And so here we're calling up, well, let's see. Here we're applying force to the confetti object. Here we're saying confetti object, or confetti is dead, and confetti update. So, one further thing is we can, and it has the same variables. This has the same variables as this up here. So we can reset our mass. Okay, right now you see how all of our masses are different because we're passing in random masses. But we can set it up so our confetti it has all the same mass. So we can say self dot mass equals 15. And so now every time that we call confetti, every time we create a confetti mover, it for the init, it takes these four variables: position, velocity, acceleration, mass, and then it goes up and it calls the function mover, so it does all of this. And then after it does all of that, we're resetting the mass to 15. Okay, so now all of our masses are 15. Okay, so I don't know how long this video is getting, but I'm going to leave it there, and then we can come back and do a little bit more with this.